Hello and welcome to this second video on probability for the mathematics AS and A levels. In this particular one, I'm going to be going over the ideas on mutually exclusive events, how events relate to themselves, and we will also be including some things about the Venn diagrams that are going to be useful when working with scenarios. Something that I want to mention that is in case any context, any concept from this video is a bit new to you. In my previous video on probability, I have made like an explanation on general things, so I recommend that you go back to it. And then, well, we are ready to dig into this. We're going to begin by talking about these two events. Remember that these events are essentially sets. So we can talk about events being mutually exclusive if they their intersection is the empty set. What does it means in terms of some, let's like normal English? Well, they are mutually exclusive when they cannot occur at the same time. This means that there is no elementary event that can favor these two events simultaneously. For example, let's take a look at this. We have, again, rolling a die, the simplest example for us to understand this. If we consider that the events are obtaining an even number and B is obtain a factor of 5, there is nothing in common between these two events because the even numbers are 2, 4, and 6, and the factors of 5 are 1 and 5. There is no number that is shared amongst these two events. So from there, these events are mutually exclusive. And as these events are mutually exclusive, they will verify what we call the third axiom. Remember, I'm not talking about the probability axioms in these videos. I have included them in the web page that you can access in the link. But the idea is that they verify this rule. This is that the union of these two sets in the probability is equal to the sum of their individual probabilities. This doesn't always happen. It only happens when they are mutually exclusive. What happens when they are not mutually exclusive? What we're going to be doing is we're going to be subtracting the probability of the intersection. Observe that if the events are mutually exclusive, then the intersection is the empty set, and the probability of the empty set is 0. So from there, we are getting that the same formula we have here. So essentially, if you know this, you can also use it here. But it's a trick that we can use if we know that they are mutually exclusive, just going from here. Or if we are asked if two events are mutually exclusive, we can also justify by observing this relationship. These two are known in the bibliography as addition laws. Here in Uruguay, we don't tend to use that name, but I don't know if other countries may do so. This is like how they are presented in our bibliography. So I believe that probably in the English-speaking countries, these are common to you. Another very interesting thing that we're going to be including now, as I mentioned, were the Venn diagrams that are useful tools that we can use when solving problems, and in particular to observing how the union and the intersection behaves. In this case, I have two events, A and B, that are shown as circles. Here, A and B, in all three scenarios. And in this first case, I'm marking here in green, this is my set A. And then in sky blue, this is the complement of A. This is the case of the exhaustive events, the ones that we discussed in the previous video. And now here, observe that this is the union of these two events, A and B. So everything that has either A or B with them, it could be both. And then finally, we talk about the intersection. We're talking about this part that is shared among them. So in our previous case, with A and B that we mentioned earlier, this would be empty and A would be over here, B would be over here with nothing in common between them. So with that in mind, let's take a look at this short example that we can see so that we can see how these things work and see if we can spot some independence events around here. We have, we're choosing a digit from 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we have three possible events. A, that is a multiple of 3, is selected. B, that is a factor of 8, is selected. And then we have C, that is a prime number, is selected. In this case, it's quite straightforward to see which events are independent or not. Let's start by writing them down by extension. This means writing them as the elements that they include. Event A means a multiple of 3 is selected. Which number here are multiple of 3? Well, we have 3, 6, and 9. Then B is the factors of 8. So which are the factors of 8? Well, we have 1, 2, 4, and 8. And then finally we have C that has a prime number. Which are the prime numbers here? Remember that 1 is not a prime number, so we have 2, 3, 5, and 7. So from here we can start looking at which intersections and which unions we care about. For example, if we have to find the probability of the union, we can say, okay, this is going to be the probability of A plus the probability of B minus the probability of the intersection. The probability of A has 3 elements, and in total we have 9, so it's going to be 3 out of 9. And then we have B that has 4 elements out of 9. Now the thing is, how many elements do A and B share? They share nothing. They are mutually exclusive. So in this case, we can say, well, then this is going to be just 0. This here is going to be 0. So we don't care about you. We just take 3 nines plus 4 nines is going to give us 7 nines. And that's the probability of the union. What happens with A and C, for example? The A and C going to be probability of A plus probability of C minus the probability of the intersection. Again, we have 3 elements in A, so it's going to be 3 nines. Then we have for C, we have 4 elements, so it's going to be 4 nines. And then we need to see if A and C share some elements. And yes, they do share elements. They share element 3. 3 is both a prime number and a multiple of 3. So it's shared amongst A and C. Is going to be part of the intersection. So as there is one element in the intersection, we have to subtract 1 out of 9. Because there's one element of the 9 possible that is shared amongst them. So this is going to be 7 ninths, minus 1 is going to be 6 ninths, so I can write this as 2 thirds. You can think about the probability of B union C. It's not going to be that hard, I hope. And then if you want to check your work, you can go to my webpage. You will have this same example and more for you to practice on this and more topics. So this has been the part on mutually exclusive events. I hope to see you in the next video. Remember to comment for anything that you may want to add or ask on this topic. Thank you.